We are beginning now talking about factoring. We will spend quite a couple days talking about factoring. There are four main methods that we are going to look at. The first of which, and possibly the most important, only because it's something that we will continuously use, is factoring out a GCF. Before I begin factoring out a GCF, I want to just review some basic concepts from some prior math courses. I am going to go through it fairly quickly. So if it does not make sense to you, please make sure you are talking to me about it in class, or if it goes too fast for you. You can either choose to pause the video to write down things like definitions and things like that, or you can choose to print out the note template off of the Moodle website. So factoring is going to be rewriting an expression as the product of its factors. Remember, product just means multiply, so I'm trying to rewrite it as a multiplication problem. So if I look at this first example, write 42 in its factored form, you learned how to do this by probably looking at its prime factorization and looking at factor trees. So I would do 42. Well, what multiplies to give me 42? 2 and 21. What multiplies to give me 21? 3 and 7. 2, 3, and 7 are all prime numbers, so I circle them. And 42 in its factored form is 2 times 3 times 7. Hopefully that looks familiar to you. You've seen that before. Greatest common factor should be another term that you're familiar with. It is the biggest number everything can be divided by. Oftentimes it's called the GCF. So if I ask what is the GCF of 12 and 18, I could find that by setting myself up some prime factorization trees. That's a method you can use if you're not very good with your multiplication facts. It's very time consuming. Because I'm pretty good with my multiplication facts, I can look at 12 and 18 and know that the GCF, or biggest number they can both be divided by, is 6. If I do the same for 4 and 8, again, I could set up a prime factorization. I would prefer just to look at 4 and 8 and know that the biggest number they can both be divided by is 4. The next thing I want to talk about in terms of greatest common factor is what about with variables? How do I find the GCF of x cubed and x to the 5th? Well, the way I would encourage you to do it to begin with is by looking at what does x cubed mean? It means x times x times x. What does x to the 5th mean? Well, it means x times x times x times x times x. So how many x's can they both be divided by? Well, if I use a fraction bar to symbolize division, I see that x times x times x at most can be divided by x times x times x, or x cubed. Since I'm concerned with the biggest number, or in this case, the biggest or most amount of variables they can both be divided by, even though I know I could put 5 x's underneath this x to the 5th, I am going to be limited by the number of x's I wrote under here. So I'll only put 3 x's underneath. And I see that then their GCF is x cubed. If I do the same thing for x squared and x to the 4th, if I rewrite x squared as x times x and x to the 4th as x times x times x times x, I see that the greatest amount of x's they can both be divided by would be x times x, which I know is the same thing as x squared. Notice in both of these cases, the answer I got is equivalent or the same as the variable with the smaller exponent. So x cubed when looking at x cubed and x to the 5th, x squared when looking at x squared and x to the 4th. That will always be true. That will always happen. Now that we've reviewed some of those concepts, I now want to look at polynomials. So what does it mean to factor a polynomial? Well, when I factor a polynomial, it's a way to undo multiplication between two polynomials. My goal when I'm factoring a polynomial is still to get a multiplication problem. Whatever I'm given, in the end, I should come up with multiplication. The greatest common factor, or GCF, with polynomials is the biggest number and or variable all terms can be divided by. The reason I say it like that is most polynomials will involve both numbers and variables. The greatest common factor is going to undo distribution. When we use the greatest common factor, we will bring that GCF to the front of a set of parentheses, and it will always be our first step when factoring. So before I go over an example on factoring, I first want to go over a review example with multiplication. And I want to find out what is 3x squared times 2x cubed minus 5. Well, if you think about what we've done in class, we learned that when we have a monomial times a polynomial, in this particular case, a monomial times a binomial, I can take my monomial and distribute it in by using multiplication. 3x squared times 2x cubed, I multiply the coefficients, 3 times 2, and get 6. X squared times x cubed, when I multiply same base, I add the exponents and get 6x to the 5th. 3x squared times minus 5. 3 times 5 is minus 15. And the x squared just sticks with it. And that would be the answer to my multiplication problem. Now that we covered that, let's go ahead and move on to this first example on factoring. And let's go ahead and factor by taking out a GCF. Well, remember, a GCF is the biggest number and or variable that all terms can be divided by. Terms are separated by a plus or minus sign, so I have two terms here. And I see that both of these terms can be divided by a 3, since both 6 and 15 can be divided by 3. And as far as x to the 5th and x squared go, the biggest number that both x to the 5th and x squared can be divided by is x times x, or x squared. Since factoring is a way to undo multiplication, or a way to undo distributing, when I distribute in, I multiplied. So now when I factor out, I'm going to divide. So I'm going to ask myself, what is 6x to the 5th divided by 3x squared? I'm going to put the answer to that inside a set of parentheses. In fact, I'm going to put the answer to that question as well as what is minus 15x squared divided by 3x squared into the same set of parentheses. So 6x to the 5th divided by 3x squared. Well, 6 divided by 3 is 2. X to the 5th divided by x squared. If I do some canceling on the side here, I notice I'm left with x times x times x, or x cubed. Minus 15 divided by 3 is a minus 5. X squared divided by x squared. Well, if I look over here, notice they both cancel out, so I no longer have any x's left. I close that parenthesis to show that I'm done, and my factored form is 3x squared times 2x cubed minus 5. So remember, our goal was to get a multiplication problem. Because I am multiplying here, I have successfully gotten that multiplication problem. And notice that when I started with 3x squared times 2x cubed minus 5 up here in the review problem, the answer I got was 6x to the 5th minus 15x squared. When I started with 6x to the 5th minus 15x squared and factored it, the answer I got was that multiplication problem. If we continue looking at some more factoring examples, there are 3 more. I'm going to go ahead and go through example 2 and 3, then I'll give you an opportunity to go through example 4 before I work it to see how you're doing with the concept. Looking at example 2, I'll start by asking myself, because I'm supposed to factor, is there anything that both terms can be divided by? I realize that both 7 and 28 can be divided by 7. So I pull that 7 out to the front, and then I determine what goes inside of those parentheses by doing 7x cubed divided by 7 and minus 28 divided by 7. Notice in this particular situation, I did not have a variable with 28, so there was no variable part to my GCF since both terms wouldn't be able to be divided by any variables. So when I pull the 7 out, 7x cubed divided by 7 leaves me with 1 times x cubed, which is the same thing as x cubed. Minus 28 divided by 7 leaves me with minus 4. Now that I've taken the GCF out of both of my terms, I have finished, and here's my factored form. And I do indeed have a multiplication problem with 7 times x cubed minus 4. Looking at the next example, I ask myself, what is the greatest common factor that both 16 and 48 can be divided by? I do realize they can both be divided by 4, but since I'm looking for the greatest common factor, I'm actually going to divide them both by 16 and bring a 16 to the front. X to the 5th and x to the 7th, well, I can do a little scratch work over on the side. And ask myself, what is the greatest number of x's both of these terms can be divided by? Well, I notice that it is x to the 5th. So I'm going to take that out as a GCF as well. And then I'm going to go ahead and divide. So I'm going to ask myself, what is 16x to the 5th divided by 16x to the 5th? Oftentimes the answer I get is nothing, they're gone. They are not gone. When I divide anything by itself, I'm always left with 1. So 16x to the fifth divided by 16x to the fifth is 1. Minus 48x to the seventh. Well, minus 48 divided by 16 is minus 3. X to the seventh divided by x to the fifth. Well, if I come over here and do some canceling, I notice that I'm left with x times x, or x squared. I close my parenthesis to symbolize I am done. I do have a multiplication problem here, 16x to the fifth times 1 minus 3x squared, so I have successfully factored example 3. If now you would like to pause the video and try example 4 on your own, you can go ahead and see how you're doing, where you're making mistakes, or if you're able to successfully do the problem on your own. So go ahead and pause it, try it on your own. And now that you've had a chance to try it on your own, I'm going to go ahead and go through the correct way to solve, or factor example 4. So I asked myself, is there anything that both 9x squared and 3x can be divided by? I know 9 and 3 can both be divided by 3. X squared and x can both be divided by x. That's my GCF. I put it in front of a set of parentheses. Now I ask myself, what is 9x squared divided by 3x? Well, 9 divided by 3 is 3. X squared divided by x is just x. What is minus 3x divided by 3x? Well, anything divided by itself is 1, so minus 3x divided by 3x is just minus 1. That is how we factor with a GCF. As I said, there will be a few more concepts that we cover in terms of factoring. However, this is always going to be our first step. If you have any questions on this or weren't sure on the steps I took, please make sure and mark those points on your notes so that tomorrow in class you can get those questions answered.